Okay, so for this video, I'm going to do without a student, just myself, but a problem that I've assigned to several students that a bunch of them have had problems with. So, there's a problem, and it's busy. It's busy. There's a lot of stuff going on. There's exponents and brackets. There's no division, but there is multiplication, addition, and subtraction. So it actually hits brackets, exponents, no division, but multiplication, addition, and subtraction. It hits all of them, except for division. But you know, we could put it in there, it's no big deal. So I gave a problem like this because you have to fully understand BEDMAS in order to solve it. If you don't understand one part, except for division, but if you don't understand one part, then you know, you're going to be out of luck. So I'm going to show you how I tackle the problem and little tips and tricks along the way. So first thing is I always like to write down how I'm going to do things first. I think top down, so I put things top down. First thing I want to tackle is brackets for B in BEDMAS. That's this one and this one. Now, you can actually do either first, as long as you finish all the brackets before you tackle anything else. So, I'm going to start from the left and go to the right. Yeah. Okay, so we'll do this guy first. Now, inside the brackets, we have some different things going on. We have exponents that I see, so that's next on our list. We've got to tackle those first. Then we have a multiplication and a subtraction. So let's look at the exponents first, because that's on our list. So the tricky thing here is that it looks like it's complex, but really, and I guess I'll call this a tip. Anything to the power of 1 to the power of 1 is just itself. Is the same as anything. So literally, if the word anything meant 7 to the power of 1 equals 7. If it was like 7,007 to the power of 1, it would equal 7,007. So, concrete example, if we had 23 to the power of 1, to solve that without exponents, I would just call it 23. Okay, so that's my first tip. Which is really nice because in this bracket, we only have 2 exponents, right here, and they're both to the power of 1. So let's just get rid of them right away. Two to the power of 1, 10 to the power of 1, but they're just the same. So the exponents are dealt with. Now, we haven't gotten it down to one term yet, so we have to leave our brackets. So we're left with a subtraction and a multiplication. And we look at our list, B-E-D-M, multiplication is first. So we do 3 times 2. 3 times 2 is 6. And we're only left with one thing to do. We're left with 2 terms, a 10 and a 6, so we can't get rid of our brackets yet. 10 minus 6 is 4. And that is all we have to do for this bracket. Taken care of. Now, you'll notice that I did one step here, and then I didn't move to this bracket. I did one step, and then another step, and then I got rid of the brackets. You can actually go either way. You can do a step here, and then a step over here for these brackets, and then a step here, then a step here, then a step here, then a step here. Or you can solve all these brackets and solve all these brackets, because anything inside the brackets needs to be solved before you can do anything else. So, that's kind of nice. I like to just have it, it's sort of, you can even put a line down here if you want. And then it sort of divides up the problem so it doesn't look so big and menacing. Okay, so next one, let's take a look. We have 4 squared minus 5 to the power of 1 plus 11. Now, our exponents are a bit trickier this time because we do have that squared right there. So, what I think we'll do is I think we'll tackle that exponent first, then we'll look to the power of 1, and then we'll add 11 at the very end. So to tackle that squared first, 4 squared, that's the same as 4 times 4. Anything to some power, that power tells you how many times you multiply it by itself. So 7 to the power of 2 is 7 times itself twice to the power of 2. 16 to the power of 4 is 16 times itself. 16 times 16 times 16 times 16. 4 16. 16 to the power of 4. Okay. 4 to the power power of 2 is 4 times 4, and that's 16. That's probably why I chose 16 when I was doing that in my head. Okay, so that's that exponent taken care of. I could do this all in one step, but I'll just write it down anyway. So we go one step at a time. And let's put some lines down here as well, just to divide up the problem. So we're just working this section right here. Okay, I have one more exponent to take care of. I'll take care of that right now. And hey, look at that. It's just a 5. Hey, that doesn't look so bad. 16 minus 5 plus 11, we can handle that. Okay, so we have a subtraction and an addition. Which do we do first? Now, again, this is why I had a problem phrased or written exactly like this, because sometimes people are inclined to do this first, because addition comes first here before subtraction. But tip number 2 is if you have addition or subtraction, or division and multiplication, they are interchangeable. Double-headed arrow. That means you can do either if you're left with just the 2 of those. Now, you can't just choose any one you want to do. You have to go left to right. You have to go from this side of the equation to that side of the equation if you're only left with subtraction and addition, or if you're only left with division and multiplication. So tip number 2 is interchangeable signs. And that would be addition, subtraction. That's one set of interchangeable signs. Second set of interchangeable signs is multiplication and division. Okay, perfect. Now, let's go back here. Again, we're tempted to do the plus first because we see addition before subtraction, but we remember we're only left with subtraction and addition. Those are interchangeable signs. We work from left to right. That means that, in fact, we do this first. 16 minus 5 is 11. Hey, we're getting there. 11 plus 11, 22. And that bracket is all done. Isn't that great? Okay, so now we've solved this bracket, we've solved this bracket, but we still have this term up here. Sometimes when I've done a bunch of work, I kind of like do something like this, and I'll just bring this down. If you remember in long division, sometimes we just bring it down so we can see it easier. That's the only reason we bring it down, just so we can see it easier and it all lines up. So I'm just going to bring this down. And that looks much, much easier. Oh, by the way, when I bring things down, I circle the signs in between and I bring them down with it. So we can actually erase those. And let's bring those signs down. So that's a plus, bring the plus down. That's a times, bring the times down. Okay, so here's what we're left with. 4 plus 22 times 3 to the power of 0. Now, actually what I'm going to do is I'm going to scrunch it all in so it looks like one nice, neat little thing. Yeah. Now look at that. This is really spread out. We brought it down. This is what we started with, and we've done a lot of work all the way to here. Now this by itself, this right here looks a little bit menacing, but I think we can handle it. So, what do we have? We have an addition, we have a multiplication, and we have an exponent. Exponents come first. And another little tip that I'll do, this will be tip number 3. If you remember tip number 1, that was anything to the power of 1 is itself. Tip number 3, anything to the power of 0, anything to the power of 0 equals 1. Now that's kind of funny, isn't it? I mean, that's a little hard to explain. And for what we're doing right now, we don't need to go too far into it. But think of it this way. We have 2 squared. 2 to the power of 2. This is a separate example. 2 to the power of 2. That means 2 times 2. Now, what if this squared then became a 0? The 2 before meant there were 2 2's to multiply it by. But now there's no 2's to multiply it by. Now there's just nothing to multiply it by. But we can't leave it with nothing. It's not nothing. It still has a base. We just don't know how many times we're going to multiply the base by itself. We don't know how many times. Well, we could say 0 times, but 0 is a weird number. So we just say 1, because we don't really know. Again, it's more complex, and there is a better explanation for that. But for our purposes, anything to the power of 0 equals 1. Okay. Now, minus that explanation, this actually makes it look a lot easier. Because this 3 to the 0 could be a 30, could be a 33, could be 337. We'll turn to a 1. Not so bad now, hey? That exponent's gone, 3, we're just left with a 1 there. Now, this is kind of neat because all we have left is an addition and a multiplication. And are those terms interchangeable? No, they're not. Addition's here, multiplication's there. Only addition, subtraction, and division, multiplication are interchangeable. You can't interchange anything else. You can try other stuff, but it's just not going to work. If it's not in the rule book, does not count, you will not get it correct. Okay. So, what comes first? Addition or multiplication? Multiplication. 22 times 1? Well, anything times 1 is itself. Kind of nice. 4 plus 22. That's what we're left with. That's what it all boiled down to. And that's a nice and easy thing to deal with because that is just 26. Okay, so that included 3 tips, what bedmass was all about, and a sort of okay explanation of things to the power of 0.